expect to find you here. I'm Olle Johansson. I'm gonna speak with you, for a while about SIP security. I'll label this talk, "You're in a maze of twisty little passages, all alike." That's a quote from the old computer game Adventure that I played 35 years ago or something. In Adventure, you walk down a cave. It was all text-based, of course. And you found many different rooms in that cave. And if you were unlucky, you ended up in a maze. And if you were even more unlucky, you couldn't find your way out. You were lost. And that's how I feel now and then when I start looking into SIP and security. It's a complicated world that shouldn't be complicated. It should be the default that we always had confidentiality on our calls in a SIP platform, that we always could trust the SIP service and the SIP service providers. Unfortunately, it's very hard to do that, especially since the RTC isn't complete. There's a lot of things missing. During this talk, I will take you down the cave and go through the tunnel, and I hope we're not going to get lost. I'm going to talk about SIP, a little bit about WebRTC, and I hope to give you some advice on how to get further. Well, how did we end up in this mess? Well, I haven't got the truth, but I have my theory. SIP, like many other things I've done during more than 30 years of working with TCP/IP, joins two different worlds. You have the Telecom world and you have the world of Datacom. In the Telecom world, the service provider creates a service and you trust the service providers. The PTT, you trusted them for a long time, all your life. And network and system security, well, it's not really the strong side. In the Datacom world, however, we never trust a provider. If I haven't got the keys that we use for encryption on one side and the other side, I don't trust it. So there are two different worlds, two different ways of thinking that met in the world of SIP. And unfortunately, the result wasn't that good. So why doesn't it change? SIP has been around for a long time. I don't know. In the end, it's up to the users, the customers, that set the requirements, that pay the money, that force the vendors to move forward. I think that there's a lack of pressure, there's a lack of interest. And I would really want for that to change. So please follow me on this journey and we'll see where we end up. I hope to provide you with some advice. I hope I'll make you angry, and I hope that I force you to rewrite the requirements for your next purchase of SIP phones, SIP services in the cloud, SIP PBXs, everything else. I'll see you on the first slide. Hi again, we're back. And yeah, as I said, I've been talking about this quite a number of times, and I feel like Marvin. Oh no, not again. Sometimes, but on the other hand, I feel like this. Let's go ahead, let's change the world. Let's make security happen. I hope you'll join me. This is me. I'm an old book publisher. I've been doing a lot of open source coding in Kamailio, Asterisk, many other projects. I'm a consultant, but I'm also a gardener, dog owner, and a storyteller. I will tell you many stories. The agenda today is to confuse you, but other than that, I try to keep a structure here. We're going to talk about the problem, we're going to go into more details about SIP, talk a bit about WebRTC, and then try to get out of the caves, out of the maze, and create a summary to lead you the way forward. And I have to warn you, like I said earlier, this is a massive slide reuse. If you listen to earlier talks by me, chances are that you've seen some of these slides. And that is a problem. I would love to have to rewrite them, redo them, and say, we're done. But we're not there yet. So, change doesn't happen overnight. If you work with security, don't give up. So we're going to focus on real-time communication security. And that's kind of special. Web security is very different. In SIP, we're setting up calls in real time, so we don't have much time for security validation, for measurements. In other protocols, losing a second or two doesn't matter. In SIP, a few seconds is a lifetime. So real-time communication security is a separate area. And of course, when we talk about telephone calls, communication started with the telegraph, right? And now we're using computers. During Corona times now, in the year of 2020, everyone have learned how to make video calls and participate in video conferences. Many years ago, that was something new. When I started talking about video conferences, doing some work in Asterisk to support video better, people weren't really interested. They looked at me and said, why would I ever use a video phone call? Today is the standard, it's the norm. And that's a good thing. So, we're going to talk about, voice on the net, right? But also video, chatting, application sharing, showing presentations, 3D holographic conferences. We have to prepare for new things. I just read an article from the Janus Meet Echo guys about implementing stereo audio in conferences. So you could place a speaker on a scale from left to right. That's something we discussed in Asterisk a long time ago. And obviously someone implemented, after a few years, something in Asterisk. So, in the future, when we have 5-to-1 audio everywhere, we can participate in these video conferences on Jitsi and say, hey, you there, up, right corner of the table, who are you? And we need security for that as well. So, this is all about conversations, right? And we're going to talk about conversations between two or more people. What I'm not going to talk about is the intrusion detection stuff or the people who want to harm you. There was a really good TADHack talk about offensive security with Sandro Gauci the other day. Look that up and you'll see the other side. And you learn everything about Marvin, the fraudster, or Adrian, the network manager. But in scope of my talk is you and me. So the problem, well, we can divide it into a few different areas. When we have a phone call, well, if you claim to be a close friend of mine, I can properly determine from the voice pattern if you are. But if you're chatting with me in real time, I probably can't. So identity can be very important. And if you're calling me saying, I'm representing this and that company or this authority, I really would like to know if you do that. In many cases, I don't want people that I don't know of to listen into my calls. I want confidentiality. And when chatting, you really want the text that you send to arrive at the recipient in the same way as you sent it. You don't want it to change in transport, right? So you want data integrity. You want to assure that message sent is the same as message received. And in some cases, you want authorization. In video conferences now, we always have an admin, but in some cases, when you talk about telephony services, you're authorized to make some calls, but maybe not others. In many solutions, we block maybe expensive international numbers, satellite phones, but could be other numbers as well. You need authorization. And in a telephone system, I want to know if you're an outside caller calling to my users, or if you're one of my users calling the outside. So authorization is equally important. And we're using more and more devices. When I started, there was always discussions about the phone on the desktop, a hardware phone. But now when we discuss solutions, we have all kinds of clients. And this leads to a very interesting problem if we want to create security solution. Because it's not only you, is it? It's you and your devices. And we need to handle not only conversation handover between devices. If you leave your car and you take up your phone, you want a conversation to continue. You really want to authorize the devices. Because if you switch phones, or if you get burglared and something disappears out of your control, you want to be able to disable communication from arriving at that device or from starting on that device in your name. So from a security standpoint and from a usability standpoint, this gets more and more interesting. How do we handle all your devices? And I mentioned this earlier on, that we live in the merger between Datacom and Telecom. And even though it's been 20 years, this is still happening. And it still leads to problems because there are so different assumptions on how to do things, who to trust, and how to set things up properly. We saw that earlier on when we worked with the Asterisk open source project, that many telecom people got the software, thought it was really cool, installed it and said, oh, I should have a phone back home. So they connected their Asterisk server to the internet with an account with the line number 1006 and the password 1006. And it wasn't such a good idea. So if we're coming from the network world, how to set up security, how to set up trust is our problem. If you and I want to communicate, it's our problem and no one else, because we don't trust everything that's in between. In the telecom security model, it's the network's problem. It's the security of the service provider that you trust. And they solve all those problems. And you have to trust them. You have no option. And these two different models keep coming back to haunt me. If you look at the SIP model, we quite often have a server in the path. The question is whether both of us trust it. Do we set up security end-to-end? Or do we want the server to be able to handle our encryption keys that we use for identity, that we use to get authorization, that we use to get confidentiality? So this is something we always have to come back to, always have to discuss. And if you look at the softwares I've been working with, Asterisk is a man in the middle. Asterisk terminates all phone calls, handles all keys, whereas Kamailio as a SIP proxy doesn't have to. Well, that's quite interesting. But in the SIP protocols, and not even Kamailio can solve that, we haven't really solved end-to-end security. And that's a problem that applies to many protocols. Good old Jabber, XMPP, WebRTC. And if you see all the new chats, they're setting up their own solutions, and many of them are doing really good. And now we finally have some open standard work going on. In the IETF, we have a working group called MLS that works on setting up solutions for 2 or 3 party calls to have security end to end. And that's really cool. The toolbox we have, well, that's a lot of protocols, right? So when we set up a SIP solution, we have TLS signaling, we have the SIP identity standards, and there are plenty of them today. We have the HTTP digest auth for authentication, and now with some new RFCs, we can start testing OAuth 2 OpenID Connect identity handling in SIP. We have DTLS SRTP for media. We have MIME integrity in the standard, but I haven't seen many implementation. And we have the MSRP chat, which of course can be handled over TLS. And the coming standard I mentioned, MLS. So the issue here is that we have a lot of standards, but we have very little feedback on how to implement them. And almost no one asks for them. Therefore, no one implements them. So we have a severe lack of experience. And now and then, I test implementing stuff, and I keep ending up in that maze of twisty little passages all alike. And I would like this to change. I don't understand why so few people care. And so few people show up in the IETF and say, hey, let's fix this. In the end, it's up to you, really. The question is, what is a secure session for you? And I see that the answer can be everything from, I want to place a call and I want no one to know about it. There should be no traces whatsoever of the call ever happening. To, oh, I don't care. I have no secrets to share. So, what's a secure session? A chat? A video conference? A video call? A phone call? What is a secure session for you? So let's talk about identity. The identity is tightly coupled to authorization, but we authenticate someone based on their identity, and you claim to be someone when you authenticate. And the question the system asks is really, who are you? And can you prove that claim? In SIP, historically, we used HTTP digest MD5 auth, but the MD5 hash is well known to be a poor hash. It's not hard to break. So in the IETF, we have taken several steps. We added a couple of new hashes that are stronger and so far are known to be more secure. We also produced an RFC about how to use your normal identity system, your Active Directory or something else, Facebook login, Google login, or GitLab login, with the OAuth2 or OpenID Connect authentication using YOT tokens. The question here is really, if you have a platform today, how do you migrate to a stronger authentication? Will you do it on a device-by-device basis based on firmware upgrades? How do you block accounts from not downgrading and accepting MD5 authentication that is known to be breakable? It's a very interesting question, something we probably have to discuss again. And if you look back, how do you separate device and a person that use the device, since a person can have many different devices? And if one device disappears, how do you block that device without blocking all of the devices belonging to that user? Now is a good time to think about this, to take what we in Sweden call a fika. A fika break is where you refill your cup of coffee, your cup of tea, maybe take a cake, a cookie, or a cinnamon bun. Stand up for a while and we'll continue soon. Oh, welcome back. The old runestones. What a way to communicate. This is one in the forest very close to me here. So many of these security systems is based on TLS, Transport Layer Security. Transport Layer Security is based on the previous standard SSL, but you have to remember that Secure Socket Layer, SSL, all versions of that is deemed insecure. You should never ever use them. And even the earlier versions of TLS, TLS1 and TLS11, is deemed insecure now. So crypto is a moving target. If you buy devices, you have to get assurance from the vendor that they will update. Otherwise, the lifetime of your device will be fairly short. For instance, now when we're moving to stronger versions of TLS and stronger authentication in SIP, you really want your vendor to upgrade the firmware of all your devices. So TLS can handle many different things. We use it for identity, we use it for confidentiality, we use it for integrity, and we use it for electronic signatures. So basically, when you use it for encryption of sessions, a client connects to the server. The server has a pair of keys, a secret key and something called a public key. And the server sends an ID card called a certificate with a public key and an electronic signature of a trusted party, a certificate authority that hopefully the client trusts. And the client validates this certificate and in cooperation with the server comes up with an encryption key for this session and this session only that we use for encrypting the SIP signaling or the web signaling or the protocol where you're using TLS. And the whole thing with TLS is that we do this without prior agreement. In the early days of encryption, we had to agree on and transfer an encryption key in a secure way from server to client in order to set up a secure session. With TLS, you don't. You can surf to any websites you haven't visited before, and we can still set up secure sessions. That's really cool. In SIP, we use this to authenticate the server. When you connect a SIP device, a SIP software, to a SIP server, we want to know that we're connecting to the proper server, not someone scamming, trying to act as it is the server you want to connect to. We use it for encryption in a session, both the SIP signaling and with a datagram version of TLS, we use it to bootstrap the media encryption with SRTP. We can also, with SMIME, use the same system with keys and with certificates to ensure integrity of SIP messages as well. In WebRTC, use HTTP quite often to connect to a WebRTC system. And then your browser validates and authenticates the web server to make sure you're talking with the proper web server. But we're also using DTLS to bootstrap the encryption of the media. So your web browser creates a certificate and a key pair and signs it, self-signing. And we use that to bootstrap, to agree on a session key that we use in the SRTP. But these are, of course, something created by the web browser in most cases and something that we use only for a session. So you can't really validate them. There's no identity in these keys or certificates that we use. There are hooks, so you can connect a proper identity system to the encryption of the media. So you know that the media only reaches the persons that you agreed with should receive the media. In SIP, we have a protocol where you want the server to contact you, so you can receive calls, but you also contact the servers to actually place calls. So the SIP UA sets up a connection to the server, validates the server, and normally registers with the server. You register to receive incoming calls. You give the address of the device to the server, so the server can contact you when there's an incoming call. The server will always provide a TLS certificate, and the client challenges that to make sure that the server has the private key that belongs to the public key in order to handle all the encryption. And the server may ask for a client certificate as well, but that rarely happens. Now, the question is, when you validate a server cert, it's signed by a third party, a certificate authority. Who made that decision? And what trust or what list of certificate authorities does the client use, the phone? Can you change that? Can you modify that? Can you update that with your own private CA? So the server may require a client certificate, an ID card, and that can actually replace the HTTP digest auth and provide an identity for the SIP user. The problem is, if you're using ingress proxies and you have separate SIP servers that act as registrars, the registrar won't be able to see and validate properly the client cert. We're coming back to that. If you only need a basic encryption, right, some confidentiality, you're sitting in a coffee shop and you don't want everyone in there to see who you're chatting with or who you're calling or get calls from, well, we can set up TLS regardless of the server certificate, and we don't care so much about the identity of the other side or trusting or not trusting the carrier. We want the call to go through. So you can do very much like we do in email. Use something called opportunistic crypto. But if you want more, and that should be doable, you need to verify and validate all the certificates. And based on the certificates used, you need to check authorization and see if this certificate is actually aimed for doing something completely different than setting up SIP sessions. And of course you need to check if they're expired. Are they still valid? In the early SIP standards, they added something called SIP-S:. The SIP URI that we use everywhere in SIP is basically a SIP colon. The SIP-S:* standards have been revised a number of times, but there's still nothing you really want to implement, and in some areas you can't implement it, and it doesn't really deliver the security you assume when you add an S. When you go to a website and you add an S to HTTP URL, https:// you really assume that you're connecting to a server with that certificate. But if you're calling someone with SIP-S:, your call can traverse many servers, and many SIP sessions in the path may not be protected by TLS, but you have no idea. So SIP-S, according to me, was a bad idea, and we can't deliver on the promise. And the standards are very complicated to parse, so we really need to remove that. I have a few presentations, and I've been trying to bring this up in the IETF, but I don't want to remove it unless we replace it with something that actually works, which I think is a good idea. But we need time, we need resources to do that. We need customers like you. Here's one of the problems. With standard SIP, the client registers, right, with a SIP server, and then we get an incoming call to the SIP server, and the SIP server says, okay, the client is registered, here's the contact URI. The contact URI is a device URI. So the server sets up a session and sends the call to the contact URI. These are two separate connections, two separate flows, right? You've seen it before, many times. So what happens if we use TLS? Well, the SIP client registers, gives an address, adds transport equals TLS. The SIP server gets an incoming call. And now the SIP server have to set up a new TLS connection to the phone. In order to do that, the phone has to have a server port open. And that server has to have a TLS certificate. And the certificate has to be validated against the contact URI, which quite often contains a random IP address provided by the DHCP server. If the client is behind NAT or a firewall, there's no way the server can actually set this up. And that is a problem. So now, when we connect, there are certain rules in the RFCs, RFC 5922, on how a SIP server certificate can be validated against the URI you're sending the call to, or the registration, or the SIP message, or the subscription. I won't go through all these details, you can look at them later, but in general, wildcards is not allowed, and we should have the domain name of the SIP URI in the certificate, not the host name. You can have many hosts, and you have them all in the SRV records in DNS. But those names shouldn't be in the certificate. The certificate should match the SIP domain that you call into. Now, in XMPP, the client sets up a connection, and the connection state means that the client is available. So when we have incoming messages, the XMPP server finds an open connection, an open TCP connection or TLS connection, and reuse that for all the messages to the client. If there's no connection, the client is offline. So this is quite different from standard SIP. Now, we created an RFC called 5626, which is quite complex, but one of the effects of this RFC is that the server is now allowed to act like XMPP. So if we have a connection, in fact with outbound, the outbound standards, you have many connections to multiple SIP servers. The server is allowed to reuse that connection for the outbound messaging. Now, if the SIP client has an open connection, it's online and available. And we can elegantly bypass most NATs because the client opens the connection from the inside. In the outbound RFC, there's a requirement to have connections to multiple edge proxies. And this is because it's really hard to notice that a TCP connection is dead. And many things can happen, especially if you're connected over mobile networks. So you want to have multiple TCP connections. So the location server, when we have calls to the user agent, can actually notice that, hey, something happened with one of your connections, so they'll use the other one. And that way we have a failover scheme. And of course we implemented this in Kamailio a long time ago. But security-wise, we can only verify the first step. We can't verify the other steps. The client doesn't know anything about what's going on. And this is, again, one of the reasons why I think SIP S:: is a really bad idea. And this is also the problem with client search. So if we have a registrar, the second SIP server to the right in this picture, that registrar will never be able to see the client cert that is used to set up the first TLS hop. Now, if it's the same boundary here, we're in the same service provider zone, the registrar can properly trust that SIP proxy to the left. So we can add information for the authorization authentication in zip headers based on the certificate contents. But if that zip server is something else, managed by a third party, we can't really trust any information we get from that. We're in trouble. So in short, if you want to use TLS properly from client to server in zip, you have to have an implementation of the zip outbound RFCs. Otherwise, you're in trouble. Or you have to have software that breaks the RFCs, but that can lead to interoperability problems as well. So we have work to do, friends. We need to kill zip as colon, but in order to do that, we need to clarify how we actually set up secure sessions. And I would like to be able to set up secure sessions so the user knows that we have security end to end. We need to standardize the usage of zip client certificates. We have a couple of RFCs that discuss this, but we haven't seen any implementations, and we need to reevaluate the requirements. There is a lot of cool stuff going on with zip certificate enrollment nowadays. We have protocols, many protocols to do that. And there is interesting work going on based on IoT requirements that we in the zip world need to follow and see if we can actually adopt to zip usage. So we need to continue to work on peer-to-peer security. We need to see what comes out of the MLS working group. But as you see, you're in a maze of twisty little passages all alike. We need to work on this. And it is confusing. If you ask me today, hey, can you write requirements on a secure zip platform? I will probably end up with a lot of, well, you know, we need to take this part and this part, but this part is not properly documented in any RFC, but we should probably do this and this and this. And it'll be confusing for you, it'll be confusing for the vendors. It's not a good situation for all of us. So, depressing, right? What can you do now? Of course, we can all go to the local village pub. Here's the Gardner Arms, and have a pint of bitter and talk about the sadness state of the world. But we can also do a lot of things. We can say that regardless of all the issues Olle had, we can always use TLS for first hop protection. Then you'll get confidentiality, and you can validate that the server you reach on the first hop is a server you trust. If you're using a provisioning system to provision your user agent, your phones, well, look into adding client certificates, if you can. There are many protocols now, like ACME and others, that you can use to provision certificates automatically and update them automatically. You need to require the vendors to do proper TLS implementations. Earlier this year, I took a couple of phones, I think it was 6 different ones. I couldn't really figure out how to modify the CA trust store. I couldn't implement client certs, and some of them, there were ways to actually install client certificates through provisioning systems, but not then. In those cases, I couldn't change the trust store. In others, I could actually, in the web UI, install client certs, but I couldn't change the trust store, and it wasn't documented what was in the trust store. And no one had an automatic update mechanism for the client certs. So it's, according to me, really bad. I hope you can prove me wrong and say that, hey, there is a phone that actually does it right. I would be happy. So require proper TLS implementations from your vendors. And for the media, require DTLS key exchange and SRTP like we do in WebRTC, and push the vendors to start leaving MD5 auth and the STS key exchange, sending crypto keys in clear text, and move to stronger, better solutions. For the WebRTC platforms, well, it depends on your usage and your users. If you want to improve the security, well, again, listen to Sanders' talk in the TADHack series. But it's the normal web security advice apply for the web and app part. But when you start setting up the WebSockets and exchanging STPs, try to look into integrating the DTLS certificates to a real identity in an identity provider like Active Directory or OAuth or SAML or something else. Always validate the certificates. So in short, clear text has always been a bad idea, right? So we need more crypto. Classic SIP with MD5 auth, no confidentiality, weak passwords, it's bad. Now, if you add TLS and opportunistic crypto, so you set up crypto for the first hop, you get basic confidentiality for the signaling. If you add SRTP with DTLS key exchange, well, you're better off. But now, if you have mutual TLS with clients and server search, you have SRTP tied to the client certificates, and then you have something I would start calling secure conversations. We have the end-to-end problem to look into. But other than that, if you trust the SIP services, you're good to go. So whatever you do, listen to Sandro. Always test your security. Always test it. Play around with bad CAs, bad certificates with the wrong names, keys that expire, certificates that are from hell. Test your implementations. Regardless if it's a phone that you bought from a vendor or a server you get open source, test them. Stay up to date. Security is never done. Build with security from the starting point of your project. You can't really add it in a good way afterwards. So when you're building new WebRTC solutions, build with integrated security in them. And don't ever stop. Security is a process. Security is changing. And security, whatever you do, has to be agile. I said earlier that while all versions of SSL are deemed insecure, TLS 1.1 is deemed insecure. We have a new kid on the block, TLS 1.3. In a few years, that will probably be deemed insecure as well. So we have to prepare to move on, to implement new algorithms, new protocols, and have a service platform that can handle that, regardless if you use SIP or if you use WebRTC or combinations thereof. Money talks. Put pressure on your vendors to do this right. Don't accept poor solutions. If needed, get help with training or with implementing or with testing. The IT security always need an extra pair of eyes from the outside. And my friend, stay curious, learn new things, follow the new standards. And that's really the most important message I have today. Always keep learning. I'm really happy that you listened to me and spent this time. I'm a bit curious how this ends up. It's the first time I do a recording of a talk like this without an audience, without being on the stage, without being that kind of nervous you feel when you're in a conference and you know your call is up and you add those lousy animations and GIF pictures to make people at least have some fun. So I really hope this worked out well. If you have questions, you know where to reach me. I hope you learned something, and hope to see you at the next conference that we run in live, or the next conference we run like TADHack online this year. Stay safe, take care, and I hope you have a nice holiday coming up soon. Bye for now.